Hello, welcome back. Episode 9, Acids and Bases. New York State Chemistry Review. In this series, we're really just trying to touch on the most important parts of every unit. Refresh your memory from things you maybe did 4, 5, 6, 7 months ago. I can't give you all of the finite details. That would take way too long. But I will get you with the most important things that you will need for your upcoming Regents exam. So, let's do it. In acids and bases, there is a main theory that the Regents likes to use, and it's called the Arrhenius theory. And this was the first acid and base theory that really came about. The Arrhenius theory, the Arrhenius acid part of this, means that anything that produces a hydrogen ion, H+, will be called an Arrhenius acid. Right? That's the only positive ion in the solution is H+. That substance must be an Arrhenius acid. And acids have a pH below 7. 7's that magic number of neutral. Below 7, that's an acid. H+ is produced, that's an acid. Arrhenius bases produce a negative ion. They produce hydroxide. Hydroxide is an OH-. If something produces OH-, it's called a base. It's the only negative ion in that solution. And they are going to have a pH above 7. Okay, NaOH is an example of that. We can look at this little scale right here. Right, this little scale. And I'm going to use this opportunity to remind you of something. So we don't have to look at the pOH. It's not something the Regents exam really worries about. Okay? But what we do want to look at is this part right in here. And just as a quick reminder, pH is based off of the concentration of H+ in negative exponent form. The bigger the number, the smaller the concentration. That's how negative exponents work. And the nice thing about pH and the way this system was created for you is that whatever the negative exponent of the concentration is a perfect relationship to what its pH actually is. So 10 to the minus 4 has a pH of 4. 10 to the minus 10 has a pH of 10. Right, so there's no reason to get confused. It's a nice, simple, easy transition from concentration value into pH. The only thing you have to be on the lookout for is sometimes they won't give it to you like that. They would give it to you like this. They would say this is the concentration of H+, right? Molarity, 0.001. And you might immediately freak out. I don't know what to do. We move that decimal place 3 times over. We can rewrite this concentration as, I don't know why I put X, 10 to the minus 3. And now we could say that if that were the concentration of H+, 0.001, then the pH would have to be 3. Okay? So that's just a nice little refresher for you. As we continue on, there are other theories. That's actually what they are called. The other theories of acids and bases. Now, other acid and base, theories, whatever. It's actually called Bronsted and Lowry, right? They were 2 scientists that expanded on the original theory, but we don't refer to them as that at this level. So when you see that, understand that it's talking about this Bronsted and Lowry theory. acids and bases are considered either H plus donors or H plus acceptors. The acid is considered an H plus donor. Now, what I really don't like about the way the Regents does this, I understand that this is the technical term in their theory, but in other acid-base theory, a Bronsted-Lowry theory, the H plus donor is the same thing as the only ion given off is H plus. It's the same definition. It's the same reasoning in both theories as to what an acid is, and that is something that gives off H plus. All right. The thing that's different is bases. So in this case, bases are H plus acceptors, proton acceptors. Okay, so anything that takes on an H plus, like when NH3 becomes NH4, this is a base because it can accept an H to become NH4. All right, so just that's how that works. Neutral solutions have a pH equal to 7. The amount of acid is equal to the amount of base. So therefore, they have equal concentrations. Have equal concentrations of H plus and OH minus. Okay? That's what pH of 7 means. Neutral doesn't mean it's not an acid and it's not a base. Neutral solution means it's equally an acid and equally a base. There are neutralization reactions that we have dealt with when acids and bases react with one another. Let me restart this. Board's running real slow today. I definitely am not a neat writer, but I'm definitely not this sloppy. When acid and base react with each other, they neutralize. Anytime you take an acid and mix it with a base, you're always going to get the same two products. One of those products will be a salt, and one of those products will be H2O. You will always produce a salt and water. And if you do this reaction perfectly between acid and base, you would be left with a neutralized salt water. We can use the titration formula to do some calculations. The titration formula is listed on the back of your reference table, and it says MaVa, the molarity of my acid and the volume of my acid, will be equal to any molarity of my base and volume of my base. Take those two things, set them equal to one another in a titration way, you get a perfect neutralization reaction. So, when you get that perfect neutralization reaction, we get a situation called the end point. And the end point of titration represents that the solution has been neutralized, like I said. And when that happens, the moles of H plus acid are equal to the moles of OH minus. Okay. Acid and base neutralization through titration creates a perfect endpoint. One thing that you have to throw into your head again, it's been a while since we've talked about this, is the word electrolyte. We talked about this earlier in this series. Electrolyte. An electrolyte is a chemical that conducts electricity or an electric current when it's in water. And the reason that something, in this case, acids and bases, the reason that they do that is because the ions separate. And in this case, it's H plus is floating around, OH minus is floating around. You have these ions swirling in a solution that conduct electricity. All right, so the three things in this entire curriculum that are considered electrolytes are acids, bases, and from way back in, I believe, the third video that we did, ionic salts. These three things are electrolytes. Okay, these three things are the only things that you need to worry about for this curriculum that are electrolytes. Now, we talked about this a little bit before. I know it seems daunting. You see minus, log, H plus. But that just really means you take the exponent and you turn it into the pH. 10 to the minus 4 is a pH of 4. So the thing that you have to know, though, is if we increase or if we change the pH value, it's going to result in an exponential change. And so an increase, for instance, an increase, I'm just going to do an arrow here, of 1 pH unit such as going from 4 to 5. We've increased the pH from 4 to 5. We've become more basic in this case. We're still acidic, but we're more basic at 5 than we were at 4. Constitutes a 10-fold. You're going to see that phrase a lot, right? But 10-fold really just means 10x or 10 times decrease in H plus. And every pH unit you move is an extra 10 times. So 4 to 5 is a 10 times decrease in hydrogen ion. 4 to 6 are 2 pH units. So it's 10 times to go from 4 to 5. It's 10 more times to go from 5 to 6. And so in total, if you went from 4 to 6, it would be 100 times decrease in a hydrogen ion concentration. A pH of 6 is 100 times weaker as an acid than a pH of 4. Right, so, for example, and this goes back to this concept, if a solution has a pH of 3, or written in this way, or written in this way, doesn't matter how you show it, the concentration of a pH of 3 can either be represented like that or like that in terms of the concentration. Or flip it, if this were the concentration, it has a pH of 3, or if this were written as how the concentration was, it would have a pH of 3. Right? So that covers us here for acids and bases. I hope that video helped you get a little quick refresher on how we do this. Don't forget, table M is indicators. I don't really need to talk about it here because that table is pretty self-explanatory on how to use. Plus, most people are very good with that. I have a video on how to do table M, so you can go ahead and check that out. Again, like I said in the last video, if I could ever figure out how to link it, I'll put a link for those that might need to watch that again. And before you go, please hit the like button, subscribe, support me. I'm just a teacher. And I hope you got something out of this and helped you prepare for your chem regents. So I'll catch you in the next video.